I'm Manno. I work at SUSE for a few years. I'm working upstream at the Cloud Foundry Foundation for about 4 years now. And this is my colleague, Rohit.
Hi, I'm Rohit Sakala, and I also work for SUSE, and I'm a contributor to the Quarks project under the Cloud Foundry community.
We are going to talk today about the work we did in Quarks, where we built operators for Kubernetes to make kubectf run on Kubernetes. And kubectf, of course, is a Cloud Foundry application runtime. And so first, a few basics about Kubernetes. Then we are going to talk about the work we did on secrets, jobs, and stateful sets, and on some of the smaller concepts and ideas we had. So Kubernetes is very much the operating system of the cloud in the sense that it gives you primitives to build your cloud with, like services, pods, and ingresses. But what we use are custom resource definitions where you can define your own kind of resource. And I wanted to show a few basics here. Like to get the custom resource, you can do kubectl get, for example, Quarks secret in all namespaces. And you have to register it with a cluster first. Custom resources are cluster-wide. So they have an array here of versions, and each version in that array contains a JSON schema to validate the custom resource you create. And then there's also the name under which it lives and the short names and so on. In your application, when the custom resource is deserialized, you get the struct like this, and then you can work with it. So all our controllers follow the common controller pattern, where we watch for changes to either core or customers. We then analyze cluster state without looking at historical events. So we don't have any race conditions, and we act on the current state. And then we try to create the desired outcome. The components we are going to show, they work without BOSH. They are currently at different levels of standalone, in the sense that some of them Helm chart and others have a Docker image. And those components are actually in use now by kubectf, and we hope that CF4Ks can find use for some of them. So the first component I want to talk about is Quarks secret. Quarks secret tries to improve on Kubernetes secrets by generating the actual credentials inside the cluster. But let's talk about Kubernetes secrets first. They are basically key value stores. They only store strings. Like you can see here, you have a username key or type key, and the actual value is protected here by base 64. And you could easily decode that, but what you would get back is still a string. It's not a nested structure. These secrets are normally used in pods, for example, as an environment variable by referencing the secret and the key of the string to put in that environment variable, or you can mount them as a volume, and then you get the directory full of files. Each file would be a key from the secret. There is also an update mechanism in that case. If the secret changes, the file will eventually change, but the documentation doesn't really say when. The thing here is that this is very much fine if your application is a 12-vector application, if it takes all its configuration from environment variables, but if it doesn't, then you still need to somehow generate an application config from those secrets. Here's how it works. So in the Quarks secret, you give a generated password here. This is the name of the secret that will be created from the Quarks secret. And the type here is password, but it could also be certificate, templated config, or Docker authentication. We don't generate if the secret already exists, so you can create your own secret like as a default. This is templated config, one mechanism we came up with recently, which we hope can help in creating these proprietary application configs. And we basically take secrets as an input here and fill them into templates. And this will create a secret where each value is here, in this case, actually a Helm template. And Rohit can demo this.
Okay. Okay, so the demo for templated config. We have already installed the operator. We have the operator, the Quarks job, and the Quarks secret. Now let's apply the templated config. Let's just check it once. Yeah, so we are creating a Quarks secret custom resource that is templated config, and we want to have a secret named templated secret, which has two keys, cert and password, and the values for those keys should come from other two secrets. The certificate value should come from generated certificate secret, and the password value should come from the secret name generated password. Okay, now let's apply these. First, let's watch over the secrets. So there, the generated certificate is being created, the generated password is being created, and then at last we have the templated secret. So here we have, as we wanted, the cert and the password from the values taken from these two secrets. So that's it. Back to Mario.
Quarks job, and Quarks job tries to improve on Kubernetes jobs, which are really simple. They have a job, you create the job, and that creates a pod, and that executes your command in the cluster. So Quarks job is like a template for jobs where you can decide if you want to run the job right in the moment you create the Quarks job, or you want to run it at some point in time, like an errand. And you can do this by patching the trigger strategy to now, and when the job is done, this will be set to done. Quarks job can also clean up by deleting the job and optionally also deleting the pod it created. Another feature we have is update on config change. You can use this to run the job again if one of the configs changes, and by that we mean secrets you reference from the Quarks job, from the pod template, right? So every time one of these changes, a new job will be created and a new pod will run. Another feature we have is Persist Output, where each pod and each pod has several containers. So where each container in that pod can write its output as JSON to a secret.
Let's do a Quarks job demo. We already have a Quarks job pod running. Let's see the example. What do we have here? We have a kind Quarks job, and we have one container which is outputting JSON into a file, and our requirement is to create a secret out of this JSON file. And so here we have output map, and the file name and the secret name is foo.json, in which we want the contents of output.json. And we also have update on config changes true. That means if the contents of this particular secret that is referenced in this Quarks job changes, then this job runs once again and will have an updated foo.json secret. Okay, let's apply this. You should see a job pod here now. Yep, we see a pod, it's running. It has completed, and we have the foo.json secret. Yeah, and we have the JSON in it. Now let's edit this particular secret. And we should see an job pod here since the reference secret has updated. Yep. We have here one more job pod created, and the foo JSON secret will get updated. That's it. Back to Mario.
The next feature is Quarks StatefulSet. And Quarks StatefulSet is another wrapper around Kubernetes stateful sets. Stateful sets are important because they have a sticky identifier, which can be used to match the volumes of the pods to the same pods later on. That's why they have state. Each pod gets a volume. And these allow for rolling updates and ordered deployments, right? And there's one drawback, however, if you get into a failed state with your deployment, you have to manually intervene and delete pods and so on, so the rollout can continue. Quarks StatefulSet can do recovery from failed deployments automatically. We also added zero downtime deployments, and like Quarks Job before, it can also restart if the config of one of the pods that's used in the stateful set of a Quarks stateful set changes. We added more features here. For example, we have canary support. So, you know, the canary in the coal mine, when the deployment fails, this little bird here tilts over, and you have to use the oxygen tank at the top to revive it. We also have AZ support, where the stateful set is spawned in each AZ. So AZs are built by attaching node labels to nodes on Kubernetes. And we also have support for active-passive probes, where we have a service that's pointing to the stateful set. And if the active-passive probe is working, there's a label that will be attached to the pod, so traffic gets routed there. Here are some more concepts in code we have which might be useful. For example, we have a binary that can wait for any pod to appear on the cluster, and we use that in an init container to stop the pod from starting until another pod is there. Then we have monitored namespaces, which we use for like multi-tenancy. We put a label on a namespace, and only if the label is on the namespace, our operator will react to events in that namespace. That means we can have our operator work on multiple namespaces, but we can also have multiple operators in the same cluster, each with their own set of namespaces. Version secrets is another thing we have to add a version suffix to a secret. And so we can kind of make it immutable. I hope that maybe we can get rid of this when the new Kubernetes version introduces immutable secrets. Or maybe we still need it and can improve on it. And then we have meltdown on resources. So if events occur very fast, we can ignore the first one and postpone it a little bit. So this protects you against the equivalent of a user double clicking on your HTML form buttons. And then we have the Gora test release, which we use in testing, and it's a small web server that can do SSL and aid in debugging. Yeah, that's it for tools you can use. We are the Quarks team on Slack, so feel free to reach out.
There's a question in the Q&A.
Oh, cool. I was trying to come up with my own one, but
It's okay. Oh.
So the service account is bound to a cluster role. So it has a cluster role binding to a cluster role, which allows read access to all secrets. That service account, I don't think it can be restricted in that case, right? Normally, service accounts, I mean, if they have a namespace role binding, they could only do stuff in their namespace. But if it has a cluster role binding, I think you can use the token for cluster-wide stuff. If if that answers the question, like role-based access, I think is a nice feature, right? It's but it's still um, the fun is over soon, right? Like there's so many permissions you can grant, which basically give cluster access. It's really hard. Like if you have a service account that's able to execute something in a pod, then it can steal all the tokens in that pod, right? So there's so many conditions where role-based access controls seem like not enough. Um, yeah, and I think that was one of the problems we had with Quarks job and the persist output feature, that we basically need a service account for every namespace this feature runs in. Otherwise, uh, the security would not be given, right? And we can't set this up then from the Helm chart, right? We like to set up things in the Helm chart because then you can audit the Helm chart and you know what kind of roles are in the cluster. But since namespaces are not dynamic and you can have multiple namespaces, the user is kind of responsible for creating those service accounts manually for namespaces that should be monitored. So yeah, lots of problems here. I I don't know of any way to do this here. Like the question is like when we have this role bindings and service account, can I make it so that the cluster wide one can't access the secret? I don't think it's possible. Um,
Maybe it's like more like a Kubernetes feature.
yeah, definitely Kubernetes, right? We just create secrets in Quark secret. We just create them, and um, I remember we were afraid that our controllers had too many permissions, right? When moving to the multi namespace feature, where we have this monitored namespace, and it turns out we already had so many permissions that it didn't really create so much of a difference to change all the role bindings to cluster role bindings, because basically what we are working on is more like um, cluster management. So it's you really go fast to needing a lot of access. While normal apps, I think you're fine with the namespace resources, and yeah, that's much more secure, of course. I think there are also a lot of projects in Kubernetes which try to simplify service accounts and automate them, or even sync them to your Active Directory or whatever. And maybe that would be a solution for that problem, right? Don't use a cluster role binding. Instead, create role bindings dynamically, so you can just exclude that one secret from that one service account. I can't suggest a solution here, though. maybe yeah, we didn't talk about this, but most of our controllers were created with the operator SDK first, and we felt that we didn't need the functionality of the operator SDK anymore, so it was really easy to remove it. But we still use the controller runtime SDK from operator SDK. That's basically our main library. And it's really easy to use the controller runtime to build your own controllers and act on resources. What's not so easy is testing, especially against live clusters. That's a huge problem because this is basically waiting for events to occur. And sometimes they don't, sometimes you have race conditions. It's much better with testing in kind, which is Kubernetes and Docker. That helps a lot because it somehow behaves more you can depend on its behavior much more than on the behavior of a real cluster from some provider. Timings are faster. Okay, I think if there are no more questions, I mean, we can wrap it up, I guess.
Yep.
So yeah, if you're interested in controllers or Quarks, come by Quarks Dev on Slack or open an issue on GitHub. Bye bye.
Bye bye.